Okay, good morning. Welcome to
FamilyMath777.
FamilyMath777. So yesterday we were listening to Patrick Honor's appearance on My Favorite Theorem, and he was talking about Barry-Nun's theorem.
Yep.
And I asked you if we did our own My Favorite Theorem, what would be your favorite theorem, and what did you mention?
I said the Banach-Tarski theorem / paradox.
Yeah, Banach-Tarski. This turns out to be a little hard, but I'm gonna show you something that's actually that sort of has the main idea and is a little bit easier to understand.
Okay.
Do you know what Banach-Tarski is?
I think it's like if you break a sphere into a certain number of parts,
I
and
think
then
it's 5 parts.
5 parts, you can reform them into 2 spheres with the same volume as the first sphere.
It's very surprising for a lot of different reasons. But what we're going to do today is we're going to study not a sphere, but we're going to study what's called a free group on 2 generators. And the easiest way to understand it, we're gonna write down some interesting expressions. But the easiest way to understand a free group on 2 generators is by analogy. And the analogy is with the Rubik's Cube. The 2 generators I'll call I'm gonna call them X and Y.
Okay.
And that means we're gonna have components like x squared, x squared, x cubed, also x to the minus 1, x to the minus 2, same thing, y squared, y squared, y cubed, y to the minus 1,
Okay.
y to the minus 2, and then we also have an element that we call 1.
Yep.
1 is the identity element. So I can think of, if I have a Rubik's Cube, I could think of, for example, x being a turn of the right side of the cube, turning it up.
Okay.
And I could think of y being, let's say, a clockwise turn of the top.
Okay.
So this is x, and this is y. Okay, now, what do you think 1 is?
It's just this position.
Yeah, do nothing. It's the identity position. This is not a free group on the cube because there is one extra, somewhat surprising relationship between x and y here. Do you know what that is? No? Do you?
I don't think so.
Okay, well, it's okay. I haven't even told you what a free group is yet, but there's an incredible simplification when you just do x's and y's. So if I do an x, a y, 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 so y, an x, a 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 y, x, y, x, y, x, y, x, y, x, y, x. What's happening? Does it look like there's any interesting relationships here?
Well, some of the red is staying on the top.
Some of the red is staying on the top. Yep, you're right.
It almost got back to its original position 1.
Yeah. Well, if you just keep doing x and y's, in a free group, you will never return to the beginning. But if you do x and y's on a Rubik's Cube...
You should eventually.
Well, what do you think? Do you think we're eventually going to return to the beginning?
Probably.
It might be. Well, we can look for patterns and see.
Give you a loop somehow.
Yeah. See. Yeah, you had the cross again.
Oh, really? Okay.
I'm not sure if that's another special.
I don't know.
Keep doing it.
It's hard to say.
Yeah.
The cross keeps coming back.
We're not really getting... Oh.
What?
Oh, there we go.
So if you do, on a cube, if you do a bunch of those x and y's, eventually you get back to where you started. And so you can imagine that I could write down a sequence And this is not the normal order you would write it in. Normally you would write it backwards. Right? You can imagine just writing it this way. If I do x, y, x, y, x, y, I just keep doing the x's and the y's, x's and y's, x's and y's.
Yep.
Eventually there's a finite sequence, and I just showed it to you, where this equals 1. But in a free group, there are no other relationships. The only relationships in a free group is if you do x and x inverse. What do you think you get?
Equals 1.
1. Yeah. So in other words, x inverse equals 1. What do you think the only other relationship is?
Y inverse.
Y inverse equals 1. And also, I suppose, x inverse x and y inverse y also equals 1.
Alright.
So, so the cube has one extra relationship that the free group doesn't have. So this is what we're going to study.
Okay.
Okay?
Yep.